Assess and mitigate the vulnerabilities of security architectures, designs, and solution elements. Architecture is the art and science of designing buildings and other physical structures. Computer architecture is the underlying structure of the computer system. Security architecture is the process of making an architecture more secure. Vulnerability is a weakness which can be exploited. IT components, such as operating systems, application software, and networks have many vulnerabilities. These vulnerabilities are open to compromise or exploitation. We will discuss assess and mitigate the vulnerabilities of security architectures are client-based systems, server-based systems, database systems, cryptographic systems, industrial control systems, ICS, cloud-based systems, distributed systems, and Internet of Things, IoT. Client-based systems. Sensitive data left behind in the file system. Temporary files and cache files may be accessible by other users and processes on the system. Unprotected local data may have loose permissions and lack encryption. Vulnerable applets. Browsers and other client applications employ applets for viewing documents and video files. Often, the applets themselves may have exploitable weaknesses. Unprotected or weakly protected communications. Data transmitted between client and other systems may use weak encryption, or use no encryption at all. Weak or non-existent authentication. Authentication methods on the client or between the client and server systems may be unnecessarily weak. Server-based systems. Sensitive data left behind in the file system. Unprotected local data. Unprotected or weakly protected communications. Data transmitted between the server and clients may use weak or use no encryption. Weak or non-existent authentication. Authentication methods on the server may be unnecessarily weak. Database systems. Deployment failures. Broken databases. Data leaks. Stolen database backups. The abuse of database features. A lack of segregation. SQL injections. Substandard key management. Database inconsistencies. Default or weak username/passwords. Cryptographic systems. Use of outdated algorithm. Use of untested algorithm. Failure to encrypt encryption keys. Weak cryptographic keys. Insufficient protection of cryptographic keys. Industrial control systems, ICS. Loose access permissions in the industrial control systems. Failure to change default access credentials in the industrial control systems. Access from personally owned devices in the industrial control systems. Lack of malware control in the industrial control systems. Failure to air gap in the industrial control systems. Organizations fail to air gap, isolate, the industrial control systems ICS from the rest of its corporate network. Failure to update industrial control systems components. Cloud-based systems. Cloud computing services are categorized into three types. Software as a Service, SaaS. Platform as a Service, PaaS. Infrastructure as a Service, IaaS. Software as a Service, SaaS customers are provided access to an application running on a cloud infrastructure. Application is accessible from various client devices, but customer does not manage underlying cloud infrastructure. SaaS models place the most responsibility on the cloud service provider. Cloud service provider on the SaaS model securing applications and data, runtime and middleware, servers, virtualization, and operating systems, storage and networking, physical data center. Platform as a Service, PaaS customers can deploy supported applications onto the provider's cloud infrastructure, but customer does not manage the underlying cloud infrastructure. Customer has control over the deployed applications and limited configuration settings for the application hosting environment. Infrastructure as a Service, IaaS customers can provision processing storage, networks, and other computing resources and deploy and run operating systems and applications, but the customer does not manage underlying cloud infrastructure. Customer has control over operating systems, storage, and deployed applications as well as some networking components. Cloud deployment models are public, private, hybrid, community. Public cloud refers to the cloud computing model with which the IT services are delivered across the Internet, such as Amazon Web Service or Microsoft's Azure. Private cloud is the cloud solution dedicated for use by a single organization. Hybrid cloud is the cloud infrastructure environment that is a mix of public and private cloud. Community cloud is a group of organizations from the business community that share the same common content such as compliance, security, and so on. Distributed systems. A distributed system is an environment where multiple computers are working together to perform tasks. Examples of distributed systems are cellular network, peer-to-peer network, distributed database management systems, aircraft control system, multiplayer online games. Loose access permissions is vulnerability in the distributed systems. Unprotected or weakly protected communications is vulnerability in the distributed systems. Weak security inheritance is vulnerability in the distributed systems. Lack of centralized security control is vulnerability in the distributed systems. Critical paths is vulnerability in the distributed systems. Internet of Things, IoT. Internet of Things IoT is the concept of connecting any device to the Internet and to other connected devices. Top 10 IoT OWASP Vulnerabilities, 2018. Weak, guessable, or hard-coded passwords. Insecure network services. Insecure ecosystem interfaces. Lack of secure update mechanism. Use of insecure or outdated components. Insufficient privacy protection. Insecure data transfer and storage. Lack of device management. Insecure default settings. Lack of physical hardening.